TPN at technophilespodcast.com. I'm David Geisler, and this is the Technophiles Podcast.
With genomics, how do we participate in this ecosystem without betting the farm and just crossing our fingers hoping that our personal information stays safe?
This week on the show, Alex and David discuss some of the benefits of storing genetic information in a blockchain. Hello, everyone. Welcome to the Technophiles podcast. I am your host, David Geisler, and tonight I am joined by Alex Sheehan, Skyping in from New York. Alex, how are you?
I'm doing great. How are you, Dave?
I'm well. It's another late night recording here for us, but I think it's going to go very well. I saw you kind of coffeeed up before we started recording, and so this show's going to get really interesting in 15 minutes. You're just going to be like, and then another thing, and another thing, and another thing.
Or I'll be asleep, Dave. I'm doing what you call the ketogenic diet these past few weeks, and I got to tell you, I'm very low energy. Turns out those carbohydrates are important for the old brain fuel.
Processing sugar, come on. Alex.
Yes, sir.
I'm so excited. You're obviously back. As I said, the last episode you were on, you're back on the show this season, and we're very, very pleased about that. I'm very excited about that. And it is your turn to be on an episode again. I'm the one who needs coffee, apparently.
Yeah, that all adds up. I don't see why.
Yeah, I was just trailing. Trailing off. Alex, why don't we tell the audience what we are talking about tonight? This is a story, or a topic rather, that you threw up on our Slack, and I got kind of excited about it because we've talked about elements of this in the past on the show in previous seasons. So let's just kind of set it up here.
Yeah, so the basic broad strokes domain we're talking about is blockchain technology, and specifically potentially how you can solve genomics with the blockchain. Maybe not solve it, but make it a little easier to research and a little more fun to research. Hopefully solicit some more participation from the general public. And I think we'll talk a little bit about the technology behind blockchain, the idea with this genomics project that we are going to link to from Wired, and then just, I guess, go blue sky with it and see what the future might hold.
Sure, I'm cool with that. On Technophiles here, over the past couple years, we have spoken about the advancements that have been done in genetic, not engineering, but I guess it's technically genetic engineering, but that's a little Jurassic Parky.
Well, I think your audience probably won't be afraid of that term in the same way that the layperson might.
What you do is you package it, and you sell it, and you want to sell it.
Oh, we can't start, Dave, because then this is going to turn into the Jurassic Park podcast, and this is not the Jurassic Park podcast.
How can we possibly?
I don't know. Life finds a way.
So, okay. Alex, genomics in general, we've spoken about this on Technophiles before. Back in season 9, we had a cast member named Drew Nowakowski that was on the show, and he literally worked with genetics in a lab in Northwestern. So he was always kind of our go-to guy for the sciencey aspects of how the genome works and all of that. I think he was very familiar with CRISPR and stuff like that. In fact, I think he was present when the Nobel Prize was won for the CRISPR project, and one of the scientists involved with that was at Northwestern, and we spoke about that about a year ago.
Neat.
So one of the things that has been very exciting about genomics is that it is growing. The ability to map a genome is growing exponentially. I remember when I was in college reading articles about one day we just might be able to map a genome, and when that day comes, it'll be amazing. Think about what we can do. Honestly, that could have even been when I was in high school. That could have been in the 90s as well, those kinds of conversations. And about somewhere in the 2000s, mid-2000s, it was finally done. They finally did map a full genome. And it was very expensive and pricey, and it took a long time because that's just how strong computers were at the time. But the short version of this story is that with every passing year, it is becoming easier and easier for scientists to map genomes, basically because computers are getting stronger and stronger, and the math is easier to execute.
So I think, early on, to store all this data, it would cost something like $10 million even a decade ago. And today it's down to like around $1,000 to get a whole genome into a database.
Oh yeah, well, it was estimated that for that first genome, it was $3 billion. That was the first pass. You know,
there was an article. This is entirely tangential to what we're talking about, but there was an article about what it would take and cost to build an iPhone in like the 40s or something.
Okay,
and it would have taken a building the size of a city block that was 60 stories tall to house the thing, and it would have
I see.
It would have cost like $60 trillion to build. And this is kind of that on a micro scale, right?
I can't help but think about that joke in Back to the Future 3 when he has to recreate the computer chip with that humongous contraption on top of the car.
Mm-hmm.
But anyway, I digress. So what's happened now is, at least as far as genomics is concerned, what has happened is it's getting easier and easier and easier. A lot, largely, companies are starting to use machine learning and technologies like that to map genomes. So much so that people can kind of buy maps of their genome, or at least portions of that, through companies like Ancestry.com and 23andMe and all that kind of stuff. They will do little mouth swabs, I think, and get versions, at least generalizations of your lineage and your genes and all of that.
Yeah, and as I understand it, that's not even going to really tell you much of a story, getting your genome mapped by itself, which is why so many of these companies rely on surveys and having it like a social network and a social effect on their websites, because that's where you learn the most. That's the data that gets fed into these machine learning models to tell you, given XYZ, it's entirely deterministic, right? Given XYZ,
correct.
What are you most likely to face health-wise or whatever?
Well, you're absolutely right. We don't know how to read a genome, but what we do is we look for patterns. Well, we look for patterns. It's that simple. And then those patterns, this percentage of people with this pattern exhibit these traits, and so that's why we will decide such about you. Only about 1 million people have actually had their genome completely mapped so far.
The people that are using 23andMe and Ancestry and all of that, they're not getting the entire genome mapped. They're getting portions of it. And that number is low at around 12 million. So like I said before, that's kind of like where the surveys come in, right? They match the parts of your genome that are mapped and match it with survey data, and then run those through machine learning models to get an idea of what you can expect. So that kind of brings us to the blockchain and why that's important. Because when we're dealing with such sensitive personal data, and you've got companies that are trying to like kind of, and I say take over the world, but I mean that in a good way. They want to take over the world in the sense that they want to have everyone's data so they can tell them about themselves and make their machine learning models smarter. But with that comes a terrible responsibility with conventional databases and centralizing all that information. With blockchain, we have a much better opportunity to decentralize that and have a way to safely store this personal data without anyone knowing what data is tied to any one individual, and have a level of trust that we wouldn't have with a centralized database.
Well, and it is interesting because blockchain is definitely trendy right now, and I hesitate to use that word because we don't know yet if a lot of people are trying to use blockchain technologies or blockchain specifically to execute certain things, and this could work. There's obviously some problems. One of the things that I've observed, I did a little bit of reading when you submitted this idea, because honestly, my only real exposure to blockchain was kind of you telling me about it when we were recording that Bubble Bobble episode. I honestly was I've only been learning about it recently, I'll admit. And I did a little bit of studying up on it, and it seems to me in general, and then correct me if I'm misunderstanding, it seems to me that you could think of, there's a little bit of a thought experiment. You could think of, one version to keep things safe is to have a piece of data on a single server and have it super encrypted and 1 million passwords and have it really fortified, have it, very secure in that way. Another way to keep something secure is to have it be redundant out in the public. And it seems like blockchain uses that idea. If you and I Okay, let's see. This is going to be a little weird. Let me try this though. Let's say you and I start a 2-person blockchain and we have written a song. I'm not joking. All right.
Okay.
All right, let's just go with this, and then you can actually say how it really works. And we've written a song, and in the second verse, you, myself, and another person have all written a song. We have our blockchain, we have a file that stays with us, and it syncs to the other 2 blockchain files. Now, if I go ahead and say, you know what? I'm going to raise a key, or I'm going to switch that C to a D chord on this song in the second verse, and I make that change to my file, if that's not authenticated to be true on the other 2 people's blockchain files, if it does not exceed, in other words, 50% or 51%, basically the blockchain rejects that change. And so when you start dealing with millions of identical representations of a data set, which could be Bitcoin and other things, a ledger, that kind of thing, blockchain naturally can reject people trying to infiltrate it. Is that kind of how it works?
In a way, yes. The only thing I'd piggyback off of that description is that it's not like you're changing the actual blocks in the blockchain. Any new data in the system is represented as a new block in the chain. So if we have a blockchain, let's say we have a very large network of millions of computers, and let's take Bitcoin, for example.
Sure.
Every new Bitcoin that gets mined is a new block in that sequence. So now our distributed ledger technology, which is, like you were saying, the ledger that everyone has a copy of, is 1 block larger, right? So we're not manipulating what exists in the past. We're adding to it. Right.
Because I think the code has a trail. Doesn't it have like some kind of key that travels from block to block to block so that you cannot insert a block in? It would break the trail, right?
Well, that, and you have a copy of it on every computer in the network. So if you try to manipulate your copy of the ledger, the network rejects that because the network knows that that is a garbage block.
It is
you're
not
a filthy liar.
It knows it's a garbage block, knows you're a filthy liar, and it knows that it most definitely is not the majority.
Yeah, and now one thing to also keep in mind, you sort of paired this idea of encryption with our classical version of computing and databases, where there's a centralized server and a centralized database that has a lot of stuff encrypted and all that. But encryption is also very important to this distributed ledger technology with the blockchain. All the data is still encrypted in these blocks. Right.
Interesting.
Yeah. So it's not so, you don't so much get the security from the ability to verify that some data is true or false.
Okay.
You get the ability to say whether data is true or false. That's like a side effect of everyone having a copy of the ledger, but also all the data on it is still encrypted. So you as a consumer, I sign up for 23andMe, let's say, I would be issued a private key based on maybe like my passport number or my driver's license, and a public key, and I would sign any data that I write to the blockchain with those keys. Which means,
pardon me, I'm gonna bring it back for just a second here. Are you speaking about using everyone's genetic information and putting it on blockchain, or were we still talking about Bitcoin? Because I was kind of setting up to go to the genetic stuff, but if you're already there, we can do it. I just want to make a distinction.
I was talking about the genetic thing, in no concrete terms. Let's say anything. So even Bitcoin
the blocks are encrypted, and you can't see what the other people are doing.
Exactly.
Okay.
Yep.
Interesting.
So
obviously when someone has their information, let's say their entire genetic map is information or data on some computer somewhere, there's some security to that for that person to know, okay, this representation of myself is stored at A, not B and C and D and E. It's stored at A, whatever that means. And I don't want it to go to B and C and D because I'm going to lose track, because once that data gets out there, there's ways that companies can celebrate that data, and there's ways that companies can exploit that data, which I expect you and I will talk about a little bit more after the break. So with putting your genetic information into a blockchain, quite frankly, I think some people could be worried about that because it feels like conceptually it's publicly out there. And I think that's kind of what you were going to. I just wanted to transition from Bitcoin into this.
Yeah. So let's say I think that's Mostly right. There's a level of trust that you have to take a bigger leap of faith with our classical model of how this data would be stored than you would with the blockchain, where let's say you're a researcher with access to this data. In our classical model, you can look up the database, you can see XYZ about you, Dave, or me, Alex. And you might misuse this data. It might not be malicious intent. You might just not really know what you're doing or know how to treat the data when you're reading and writing the data. You could lose your password. Someone could get your personal computer and have access to all this data. And those are all concerns with the consumer products like 23andMe and Ancestry, where you're not only giving up your DNA, you're filling out all these surveys and putting your address and a list of all your fears and all that in.
And because they're building maps, frankly, of all these different things. Because genetic information is stronger when it's grouped, clearly.
Well,
if it's just a single person's genetic map, fine, cool, there it is. But if you don't have anything to compare it to, we were speaking about this in the beginning of the episode. Once basically what happens is if they say, "Oh, this is interesting. These 500,000 people that have this pattern of GATC of millions, blah 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 blah, they all were 70% likely to get cancer in their 70s or something, or they were 20% likely to have kids with blonde hair, and it's all just because we're just matching those patterns. It's just fingerprints. You know what I mean? And so so a single person's genetic map alone, without the knowledge of the others, isn't that valuable. It's about bringing it all together. And so when you bring that data together, it is stronger. And scientifically, that's a good thing. And potentially that can also be a scary thing.
I don't even think that the information about a person's genome is what people are worried about, right? Like that.
Okay, well, let's talk about it.
That could get hacked. Like if you have a database of just long strings of GATC over and over again,
right? That
doesn't matter if that gets out, right? That's what the human genes look like, right? I guess what people are worried about are like passwords and dates of birth and addresses and phone numbers, which all accompany that genetic information in these databases. And that's the problem the blockchain's trying to solve, not necessarily the sequencing or the snapshot of someone's DNA.
Oh, okay.
So like the classical model of computing and storing and all that, that's fine for that type of data because there's not much you can tell about people based like, someone's going to get cancer. I don't know who that person is. I don't know what their address is, but all of a sudden, if we hack 23andMe's database, we do know who those people are. We do know where they live, and who knows what else. If they share passwords across multiple systems, now we have their Uber account, now we have their Gmail account and all that. So that's what people are trying to solve with the blockchain. And that's actually kind of a good distinction, is that blockchain isn't going to solve every problem with like security and computing, and it's not always going to be the best tool for the job. And like you said early on in the show, a lot of people are trying to fit a square peg in a round hole. I think it's going to be a combination of like these existing technologies paired with blockchain to make a tighter fit for a lot of these consumer and SaaS products.
So what's the benefit of using a blockchain to store this data, in your opinion, then?
Benefit, in my opinion, is that each block can be a representation of someone uploading their DNA to the company, either 23andMe or Ancestry, and have all of their personal information encrypted on the blockchain, and have it accessible in a way that you're not able to misuse or be manipulable or whatever. If you're a scientist who doesn't know how to use a blockchain or how to use whatever, you can now use some program that sits in front of you and have access to the genetic information, but not necessarily have any access or notion of the identifying information of the individuals.
Okay. Yep.
What this also solves is the economics of this entire venture. Is that, like we said before, there's only around 1 million people who have had their entire genome sequenced. Further, there's only about 12 million people who have signed up for 23andMe and Ancestry to have part of their genes mapped. And as you know, there are a lot more people than that on Earth. And more data equals more insight into this kind of study, right? The more the better, as you said earlier. We can do a better job.
I think so.
Yeah, no, it's
the more the stronger.
Yeah, strictly from a computing standpoint, we can train better models for machine learning if we have more data available to train on, right?
Right. Definitely.
So this makes it economically feasible to pay people to upload their DNA. Let's take another concrete example of something like Wikipedia. And I think Wikipedia maps pretty well to this problem because you take all of the people that have produced content for Wikipedia, and they've done it out of the goodness of their own heart. There's some level of altruism inherent in them. So they donate their time, their knowledge, their research, and they write a cool Wikipedia article. Great. They get a cool pat on the back and all that good stuff. If Wikipedia existed on a blockchain and had some sort of token mechanism like Bitcoin or Ethereum or whatever, it would be economically feasible for Wikipedia to pay out for these mundane tasks of writing articles. If it were economically feasible for Wikipedia through some sort of cryptocurrency to pay out for this work, way more people would do it. And it's the same with this. Right now, if I want to donate data to this project, I have to sign up for 23andMe, pay $100, put a cotton swab in my mouth, send it back, and then forget that I did the entire thing. There's not a lot of like active participation in this process other than swabbing the inside of your mouth. If, let's say, 23andMe said, hey, here's our kit, swab your mouth. Oh, also, by the way, here's 100 23andMe coins. And over time, the value of those coins increased, then guess what? I am incentivized extrinsically to participate in this system. So that's two problems that blockchain can solve. The one of anonymization and securing your information, and also participation, because that's going to be huge to train models to make better predictions.
Because right now, 23andMe and companies like it, they're framed more as a product or a service. Like it's something you're purchasing. And their marketing, which isn't untrue, but their marketing definitely focuses more on these kind of emotional things you can have when you learn about yourself. And that's fine. That's what they should be doing. But like you're paying them to give them that data.
Yeah. Yep. And that's fine, right? Like, great. Capitalism is awesome. Round of applause for that. If they can get away with doing that, and if there's enough people with decent hearts to give them their DNA, they can do a lot of incredible things, I'm sure. That's going to happen a lot faster if...
do you suppose a company like 23andMe, I won't say them specifically, but could a company like 23andMe then take that data and sell that data a bit like what a bank does with actual money? Oh yeah. That's how this works, right? That's probably where that's probably their real business. That
data is definitely a commodity. And that is how I see their long-term monetization strategy going, because $100 a pop for a DNA test isn't going to do you much compared to like, you're not going to be able to pay your investors back with that in 10 years. You need to make a play at the data and commoditizing the data. There's already a company called LunaCoin that I believe does something like this. I know LunaCoin exists. I don't know what the exchange rate is right now, but essentially they're trying to do kind of what we just described, right? They're trying to do DNA sequencing in a way that is open and in a way that is lucrative. So there's the problem that I just described is what they're trying to solve, right? There's no extrinsic motivation to upload your DNA to the internet or to some company.
Right. Unless you want the emotions of knowing that you're 1/4 Cherokee or something, and that's really all they can really like sell to you.
Yep. So with Luna, the same kind of physical transactions happen where Luna sends you a swab, you send it back. Luna processes that. The medical industry, scientists, universities, whoever buy that information and study it, right? With Luna, all of those transactions are paid for with Luna coins. So you are paid to give your DNA, and the industries using the DNA information pay Luna with the coin as well to receive the information.
And let me ask you this right now. I'm enjoying what you're saying, but just to be difficult for a split second, when does Luna coins stop being monopoly money and start having a real value? Is it when it has to build up like a cryptocurrency, or is it just that it has to be there has to be a perceived value and then then it's a currency? What's the plan here?
Yes.
Both,
right? So, generally with cryptocurrencies, there's a number of exchanges that they trade on. And those exchanges, you can trade crypto for crypto, you can trade crypto for fiat, you can buy in with fiat for crypto, and those exchanges set the price of the coin. There's a lot going on right now with the SEC trying to figure out if all of this is securities fraud. There's a number of tests you can do to see if it is. For instance, the value of the token can't be derived by the finances of the company that controls the token. So for instance, if I am Luna and I raise a ton of money and I use that money to build like services that'll make the token more valuable, that's illegal.
Right, of course.
If there is any perceived notion on behalf of the consumer investing in this, in Luna, that I'll get a return on Luna coin, then it's illegal. There's like a couple more tests you can do to see if Luna coin is illegal or any cryptocurrency is illegal. All of that's still kind of shaking out right now. I think we'll find out within the year, though, the right way to structure these types of companies. But to your point, the value of Luna coin is very much derived from the exchange in these markets. There is inherent value in them in the sense that they are a value store for the transaction of DNA data. Mm-hmm. But the real value, like the real way that a contributor of DNA is going to get paid, is if the price of these coins goes up in the exchanges.
Right.
Otherwise, it's like 35 cents.
So what does it take? In the beginning, it just takes a couple people that are willing to believe in it, and then this value starts to raise.
Well, it depends, right?
How does that work?
So a lot of these, and I'm not even sure how Lunacoin works, if it's its own blockchain or if it uses Ethereum or IBM's blockchain or something like that. But yeah, essentially you need a network of people willing to do work on these blockchains, first of all, to start minting the coins. You could use a meta API for something like Ethereum, where you're buying your coin, you're buying Ethereum and minting your coin with that, and then you kick back some value to the Ethereum network with every transaction. It's a leap of faith in a lot of cases, and we're kind of in a weird bubble right now where, because of the rapid expansion and contraction of the value of these things in exchanges, a lot of cash is flowing into this ecosystem, which is propping up the value of these coins.
Okay. All right. That's interesting because, and we'll probably go to break here in a few minutes, but as we were talking about this in the beginning, I thought this was going to be a story essentially about Gattaca, honestly, as you were putting this together. I thought this might be what?
I got a couple things to say about Gattaca.
Okay.
Great film. Fine film. Let's say the runtime is 90 minutes.
I enjoy it.
I'm with you for 80 minutes.
Okay.
But as soon as the director asks us to believe for 1 second that a kiln is going to have an on switch inside the kiln, I'm done.
Okay.
I'm done.
Right. I offer you this.
Oh, he did it himself. He made his own kiln. No, hold on.
No, I don't think that at all. What if it's just like a smart home situation where he sets it as a timer and he executes the on switch from inside? He pushes the little on switch from his phone inside, Mr. Jude Law or whatever.
I saw nary a phone in that movie. That's actually the utopia I want to live in, is one where the kiln knows I'm inside and knows my motives.
And is ready to turn on for you. It's tracked your entire trajectory of your life patterns, and it understands.
Mr. Sheehan, are you ready to make the transition?
Yes, Kiln. Yes, Kiln, I am.
I am ready, Kiln. Thank you. No, but also though, what I was thinking is, I thought what I was envisioning was a story about, and I think it still is this a little bit, though I'm not trying to pigeonhole it into what I'm about to speak about. But I thought, oh my gosh, wait a second. If your genome's out there and it's public, you could be profiled. You could be profiled when you're trying to get a job. I could easily see a future 20 years from now, 30 years from now, 10 years from now, 50 years from now, where people are just flat out getting jobs or not getting jobs. You got to take a blood test and they say, well, you're 70% likely to whatever, get cancer or have some kind of health thing. We aren't going to take that risk with our company's insurance. Get out of here. We're going to hire someone else.
You're absolutely right.
That's the fear.
Yeah.
And I think that's why sometimes, even though it doesn't connect directly, but sometimes people do get a little bit scared about, they might be curious about their genetic map, but they are probably, they being anyone, I can see someone being tentative because the idea of sharing your map is a little scary. Yes, maybe you do want to help science and add to the data set and do all those kinds of things. But at the same time, once your map, which is connected to your account and your credit card and your address and all these things you're talking about, Alex, once all that is connected and they can essentially identify who is connected to each map, that can that's why I said earlier, the more data together, the stronger, not necessarily the better, because that strength can also be used to profile and to kind of do a little bit of a Gattaca thing a little bit.
Yeah.
You know what I mean?
Yeah. And I'm willing to shortchange the insurance company because actuarial tables are accurate enough. They have possibly the largest building square footage wise on Manhattan. MetLife does. So we don't need to give them any more ammunition to profile people with. And that, like what you said, is exactly right? Like, people are wary about this because if a database gets hacked, right now with the conventional database and servers centralized with one company, all that information is associated with the genetic material. With these new ways of storing the information on blockchain, all the personal information, like the people researching the genome, I think that's important too. There's a distinction between 23andMe and Northwestern, right?
Yes.
So Northwestern doesn't need to know identifying information about an individual. They just need to they just need to see what the genome is, right? Mm-hmm. An organization like Northwestern that's doing pure research, they don't care, right? So there's no reason that that identifying information would have to be stored or available to them anyway.
I agree.
The 23andMe's, the Ancestries, that's a lot of identifying information that's valuable info for other companies, whether it's insurance companies, whether it's a bank when you're signing a mortgage, whether it's whatever.
A company like 23andMe, they're just collecting data to sell it. As I asked you, and you basically confirmed essentially. So we are going to go to break, but what I do want to continue talking about when we come back is this a kind of a question that I ask you, or this idea. I'm trying to bring this all together a little bit here. You can see a situation where, oh, cool. I'm just a normal person. I'm happy to share my genome for the sake of science because maybe my grandchildren will be able to have some kind of procedure done. If they're at 6 years old, they can be predicted that they might get cancer at 40 and something can be done ahead of time. I'll happily, submit my drop into the bucket for that data to help science in general. But oh boy, it sure is scary that it could get hacked and all of a sudden I won't be able to get a job in 20 years, which is a little, whatever. Or my kid won't be able to get a job because I had a trait, and then there, blah, 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 blah. And so it either gets positioned as a Hallmark card, which is 23andMe. It gets positioned as a beautiful, loving, emotional experience to learn about yourself, which I think that is not untrue, that company provides that, and the people pay for it. So it's like, oh, either I do the Hallmark card or I do Lunacoin funny money, which apparently is going to mean something, but all the time I'm still taking a risk, but I kind of want to help science. That's what I want to think about, and that's what I want to talk about when we come back from the break.
Great.
Sound good, Alex?
Sounds great.
Awesome. I'll see you in like a minute and a half.
Yeah, that sounds about right.
stuff of life. Just give us your life stuff, maybe it'll be alright. Because we have this digital coin that's almost currency, and we believe that digital coin will be increased, you see. You won't need no money for this plan. You won't need money, so open up, man. We need your genome now. Just give us that genome now. We need your genome now. We want to rid the world from all disease. I just hope that my life doesn't get hacked. Passwords, cards, they'll know where I'm at. I'll change my name, I'll live abroad. I can't believe I swabbed my mouth for you. They have my genome now. They have my genome now. Just gave them my genome now. I hope I help rid the world from all disease. All right, we are back from the break. I am David Geisler here with Alex Sheehan, and we have been discussing what's up with these motions.
I don't know. I'm just trying to be your hype man. I'm trying to be your.
That was hypey.
Was your? I'm trying to be your P Diddy. I'm trying to be P Diddy to your Notorious B.I.G. Or was it Tupac? Who was?
I get it. I don't know. It's all a little gray for me.
R. Kelly. No, he's Ignition. He's Ignition.
Alex, we're talking about genomics and the blockchain and all that can be deduced from the relationship of these two technologies. Genomics isn't a technology, but I'm going to keep on going here. So I presented kind of a big question just before our break. You know, a normal person going through life, where I'm trying to see this through their eyes, or rather, how does a company entice someone to share their data for the I mean, at the end of the day, I think by the end of this episode, we're trying to figure out a way to celebrate sharing the scientific data and not having it go poorly.
Yeah.
And so how do you feel about that?
Yeah. So you stated it perfectly. We all want to participate in furthering the human condition. A subset of that is collecting information about ourselves, looking inward, and being able to predict things in the future that could help us out, because we need all the help we can get. With genomics, it can be scary, like you said. How do we participate in this ecosystem without betting the farm and just crossing our fingers, hoping that our personal information stays safe? And
right.
I'd like to say that that's kind of like centralized databases are a little bit of that gamble, where picture it like this. There's one big warehouse that everyone's stuff is in. Mm-hmm. There's locks on the doors in the warehouse, but a lot of people have keys to those locks. If one person screws up and someone who shouldn't be in that warehouse can get into that warehouse.
Yeah, they lose their key. They drop it on the street, whatever. They give it to a friend.
Everyone's stuff is there, and they can sift through it and sell it, and there goes all your stuff. Now, picture blockchain as a storage warehouse, right? You know, they have like the 14 floors. It's a whole city block, and there's a bunch of different storage units inside of it. Each one has a padlock, and only you have the keys to that padlock. I have the keys to my padlock. You have the keys to yours. On each one of those little garage doors, there's a window. And inside, if the researchers want to peer through and get a look at your haploids and your gametes and all that, they can do that. But only you have access to opening and closing that door with your data. All your personal stuff is in nice little boxes, nice opaque boxes inside. No one can see that. No one can get in because you have your keys. That's what we were talking about earlier with the public-private keys and how you sign this information using those. That's a thing you keep scribbled down on a piece of paper and you put it in your filing cabinet at home because it's highly unlikely that anyone's ever going to be able to get to that. And those are the keys to your warehouse, to your personal little warehouse that has all your stuff in little boxes that you let the scientists peer through the window and gather the info they need, but the info they need is separate from the identifying information about you. And that's why blockchain is safer for this type of work and this type of access to this kind of data. That's all I've got.
There it is. There it is. That's great.
Yeah.
That's wonderful. That's the that's the end of Act 2, everybody.
All right.
We'll see you next week.
I assume my check's in the mail, Dave.
So why might what's your takeaway from this topic? Is there a reason for companies? Are there appropriate ways to handle this? Inappropriate ways to handle this? Is there a reason for not just we've been exploring why would a normal person want to submit this data, but let's look at it from the other perspective. Why would a company get excited about this kind of technology or this way of executing on this technology?
Blockchain or conventional databases?
Well, I think blockchain.
Yeah. Well, that's for the companies that are harvesting the data. That's going to be a marketing play for them. They're going to be able to say, hey, look, these other guys, they use a centralized database for all of your genetic information. We don't. We use blockchain. We operate on a series of trust and encrypted data. We can't see any of your identifying stuff. Here's a cotton swab. Put it in your mouth. That's going to be a way to sell a lot of the little kits. And by the way, if it's on the blockchain, we also have this coin that in the future could be worth a lot of money. Here's 100 coins with every cotton swab you send to us.
Yeah, actually, and it's actually kind of no harm, no foul in the beginning. Okay, fine, you have 100 coins of funny money, but it could mean something later.
Yeah, it could be a good chunk of change. If you had 100 Bitcoin in 2009, that would be a lot of information or a lot of money today.
Mm-hmm. They're not asking for a real world dollar for 100 of these and maybe it's worth later. They're just, if it's valueless in the beginning and it stays valueless, nothing's lost.
Let's say the coin is 3% of a penny when you get it. Great. Buy more. Because
right.
in 10 years, it could be $10,000 per coin.
Sure.
So that's the person harvesting the information. Now, the researchers, they have a secure way to take a peek at way more information because you, the intermediary, have done a good job marketing this, and you have way more data than your competitors. And you can say, hey, Northwestern, have at it. Here's an API you can write programs around so your scientists can have sort of a read-only copy of all this data, and they can build their models. They can study it, do whatever they want with it. Oh, by the way, just so you have a login, pay us 100 coins. We'll give you a login, and you can access all the data. That just means you have juicier data as Northwestern to train your models on and to do whatever research you need on the actual code itself. So all of this hinges on incentivizing the users to participate. And I think having intrinsic motivation is great. That's how Wikipedia was born and continues to thrive. But pairing that with extrinsic motivation is sort of a home run because that casts a much wider net for people who want to participate. Because even if you don't...
It's interesting.
Yeah.
No, what's up? Even if you don't what?
Go ahead.
Well, I was gonna, you got me thinking about Wikipedia, and even through the course of this podcast over the last 8 years, we've followed Wikipedia, and we've had times on this show where we've talked about stories about Wikipedia. There were times where they were fairly authentic, and then all of a sudden it was becoming, they were really getting some, their quality control was really going off the charts there, I don't know, 6-7 years ago or something. And then they actually had to hire people to start checking and authenticating these things and cleaning it up. And it's coming back around a little bit. As Jake Gill, another one of our co-hosts, often says, it's a great place to find sources, like, oh, that'll lead me to more links. That's fine. But ultimately, the data that is in Wikipedia can be trusted more now than 7 years ago.
Absolutely.
Because they had to work in some systems that would verify, I suppose, that data.
Yeah, moderate.
Moderate. Yeah, there we go. Is there a possible risk of that with this plan, with using blockchain?
Well, I'd say that...
For genomics?
No, I don't think so. It's also a different kind of data, right? Like first source knowledge is still a human away from absolute truth about a thing, right? So take, I don't know, how long it takes for an apple tree to grow.
Mm-hmm.
There is how long it takes an apple tree to grow in the physical universe. And then there is someone's perception of how long it takes an apple tree to to grow. And that person's perception of that is what gets written to Wikipedia. So even though it's a person observing it with a stopwatch, seeing it grow to an adult tree and producing fruit and all that, that's still knowledge that is sourced from a human. With genetic data, it's sort of like a more raw form of how do I say this? Okay, so like
it can't be interpreted.
Yeah, it's static. It's a thing that is fact, right? We have come up with ways to observe how this physical thing functions in the universe, and those rules are trusted by us and by other people, and we can trust that they know what the language is that we're describing a gene sequence in, and they can trust that we know that we're speaking the same language. Language is a good way to describe this, right? You and I speak English, and part of the reason that works is because, yes, I speak English, I can read, I know that a paragraph is a paragraph and I can understand it. You can also speak English, you can read that same paragraph and understand it. But on top of that, when we're conversing, I can trust that you understand what I'm saying, and you can trust that I understand what you're saying.
Fair enough.
If you spoke Spanish and I spoke English, I could not have that same level of trust. Do you get what I'm saying?
I see this. Yep.
So that's kind of the same model of the blockchain, is that since we're using a distributed ledger, and again, this is kind of separate from the security aspects of it, but since we're using the distributed ledger, we can all trust that everyone is speaking the same language and everyone has the same copy and we're all on the same page with how this data goes. And because of that, that's different than like a first source recording of my observation of how a thing is going.
Yes, of course. And I'm also realizing that the motivation for someone entering data into Wikipedia, we could, in this conversation, posit that they're doing it to help humanity. But a lot of times I think it's people just being excited about their own knowledge of something, and they want to share that, right?
Yeah.
And I think that's a different interaction.
It's still intrinsic motivation, and I think it's still pretty powerful intrinsic motivation to do the work that they're doing. But like you said, right, they're different motives, right?
Because you can't be like, oh, my genes are so good, I just got to share my share my genetic map because I just care, because I want to share it, because this is how good my genome is.
I think you hit on a very important point, right? You can't show off how good your genes are. You could try. You're probably a monster if that's what you want to do. But you can't do it in the same way as you can show off in a Wikipedia article that you know everything about honeybees and their migratory patterns. Or do they even migrate? Right. I don't think so. Bees are very smart. Bees are great. They know to stick around and stay in the same place. Did you know honeybees, if a drone finds a source of nectar and pollen to bring back to the hive, they can do a little dance to show all the other bees in which direction to fly and how far. Isn't that amazing?
So they do that locally. They go back to the hive and communicate this dance, which is essentially a set of instructions.
Yes.
It is unlike an ant hive where they just keep dripping the goo and they say, follow my goo.
Exactly. There's no
Fascinating.
Goo. They don't waste any goo in the bee world, Dave. No goo is wasted.
No, it all goes to honey.
It all goes to honey and all that royal jelly. I don't know why you're laughing. This is a serious matter. Honeybees are in crisis, Dave.
That's a thing. Anyway.
I know. Dave, of course it's a thing.
Mm-hmm.
I don't joke around about honeybees, Dave. There are two things I don't joke about. That's blockchain and honeybees, Dave. We're gonna do a bee episode.
Well, we did a bee episode about 3 years ago about a company that was putting sensors on the bees' backs to track. I think the migratory patterns.
You know what that is, Dave? You know what that is?
Maybe they do migrate.
That's coming full circle.
Yeah, I suppose. If by full circle you mean
full circle on the tangent, of course.
Skeletal tangent, yeah.
Yeah. Not on blockchain. No. What were we talking about? I am so sorry.
Well, we were discussing. Well, we were joking around about someone can't show off their genes. So if you are if you're a user and you want to participate and you want to add your data to the data set, there's not a lot to necessarily gain from it.
Right.
Not even not even the pride of knowing all about the honeybees, as you put it,
Yeah, like quite frankly, we look at the numbers between people who have mapped their entire genome and the people who have signed up for 23andMe and Ancestry, and that's a 12x multiple of people. So they're doing
So
it
does it
because they're doing it because there's a cheaper alternative with good marketing.
Mm-hmm.
They still have to pay into it. They still have to be told what it is and how to do it and buy a thing.
23andMe, what is it, a couple $100 to like get yourself processed, or is it like a $900 to do 23andMe? I've never even really looked. Do you have any idea?
I did it
because a full genome is around 1,000 right now. Yeah, a full genome is around 1,000 right now.
It is nowhere near that. I did it. Lauren and I did it when it first came out, just because.
Oh, really?
Yeah, when just any new startup, I usually try and participate in some way.
That's cool.
Mostly so I can get my name as my username, which only worked with Pinterest. So I'm pinning as me. But with 23andMe, I think it was somewhere around like $99 when it first came out. And it was limited what it could tell you, both by FDA regulation and just a shortage of resources.
Sure.
But it was still a marketing tool that got me to sign up. There was
many scientists feel that within a couple years, a full genome is only going to cost about $100.
Yeah. I don't see why not, right? If there's,
at that point, you can almost see maybe funding can come from an outside source.
I guess
you don't have to talk to people. You don't have to talk each user into spending the money or giving them funny money or anything like that. I'm not sure.
Well, I think that. So there's degrees of the marketing push for that. There is buy a package, give your DNA. There is receive a package for free, give your DNA. Or there is receive a package for free and get paid possibly a lot of money. Right. And so that's why the third option is clearly the best. Because like we've said probably 10 times now, we need to capture more than just the willing participants who are doing it out of some sort of altruism or curiosity. We need to capture most people, I feel. And that's going to pave the way for mapping the entire sequence and making that economically feasible. And not only economically feasible to map it, but economically feasible to pay people for their genes.
Oh, man alive. So do we have to be worried? I don't want to get all apocalyptic, but do we have to be worried 30 years from now that we're going to be profiled and not be able to get a job or not be able to give birth to a new married couple can't have a baby because because they would have to be the identity would have to be placed with the genetic information.
Right. And I think that those types of moral questions are more aligned with the kinds of research and medical applications of this research than it is with actually capturing the data. Right? Like when we're talking about like editing genes, when we're talking about CRISPR-Cas9, we say, okay, yeah, it's great to use when we're trying to cure cancer, but maybe it's a little morally dubious if we're trying to create like children with all blue eyes and brown hair, right?
Right.
And those are the things that are...
Yeah.
Those are the things that are just like more closely tied to the research and application, which is on, if we're talking, let's say LunaCoin again, right? We have us, the user, the intermediary, which is LunaCoin, and the research arm. That's more closely tied to the research arm than either Luna or the users. So I don't know if this like way of capturing the data is necessarily inherently nefarious in any way, or we should be worried about it. What we should be worried about is the practical applications of studying this and knowing what it does and how to manipulate it.
I agree. I think more information about Yes, I think this is a good thing. There is technically, I'm not trying to be the shock and awe guy.
No.
I'm not trying to be that in this episode. I'm providing some of that because otherwise it's us just thinking genomics is awesome,
Right,
you know?
Yeah, what could go
Which
wrong?
is cool
I
because
think it's fine.
it's, yeah, a little bit. And I'm trying to do both sides here a little. Perhaps there's a version where once we have such a good understanding of all these different percentages of our ability to predict things about people's health and other things like that, I suppose you could have like a company outside of not using blockchain or genomics, but you could have a company say we require a blood test from you, and this is getting ridiculous, but like, oh, the government, you require a blood test to have a baby and all that. But that's now that
I don't even know if that's that ridiculous, because you look at a superpower like China who has a one-child policy, that's aligned with what you're describing right now. So I don't think it's that out of the realm of possibility.
I know. I'm trying to not get too crazy town, but I agree. So what I'm saying is, could all of this? I can't believe I'm saying this because I'm not interested in stunting scientific development. However, like if all of that data is out there, that could empower some of these things I'm speaking about as well, as well as save lives.
I think the data and the research is amoral. Is that the right term? I think it is. Void of any moral implications. The data is the data. It already exists in the universe. We just don't know how to read it or capture it yet. Yeah. The part of it that is morally dubious and has implications for humanity and mankind is the application. So whether that application is a simple blood test that can predict whether or not you're going to die when you're 50, so a company won't hire you because they want you till you're 65, whether that means that your insurance premiums go up because you are a higher risk for some types of diseases, those are the morally weird things that we can get into, but those are all applications of the technology, of the research. And there are already bodies outside of government like trying to ask these questions and solve these problems, and their universities and their companies and their large consortiums of people and experts to try and figure out where those lines are and what's acceptable and what's not.
This is similar to something that we circled around on the HomePod episode, where you basically said, if my smart house does all these things for me, I'm still going to go to the gym. If someone chooses to not go to the gym, as an example, that's a human condition conversation, not necessarily a conversation of the technology. Mm-hmm. But I mean, it's important to kind of balance those two things as well, Yep,
I agree. The two concepts are married, right? The data and the research is very closely tied to the application. You look at something like DeepMind, which is the deep learning arm of Alphabet. There's a lot of PhDs doing a ton of research on DeepMind and ways that it can be used. And then there's application arms like I forget what it's called. Something Health is using DeepMind to analyze medical records, and like that's the practical application of it that could be misused in some way. So to say that they're entirely compartmentalized, I think is a little foolish, because we don't have the tools now to do the things we're describing. We potentially will have the tools later to do the things we're describing, and we'll only have those tools because of the research and because of the data. But I think in a vacuum, the data and research needs to happen because we need all of the help we can get as a species.
I agree. I think at the end of the day, of course, the data can be empowering. And I guess if you're just a normal, regular old human going through life and you're hearing this episode, all you can do is just when you do see articles about this kind of technology, we will just have to pay attention as these things go. And eventually there'll be legislation or different things. It's the same kind of things we're dealing with now in other areas.
We're dealing, freedom of speech and the internet is where we're dealing with this now in the legislature and in the public. And obviously there's more. Like there's women's health issues, there's gay rights, even though it's the law of the land. You get it, right? So I think activism and being civically minded is the key here for us as a species to figure out the best way to apply this information.
I agree. I think on that we're going to get out of here, Alex. I agree.
All right, I'm gonna go protest something.
No, that is fine. Alex, thank you again for being on the show. I'm excited to see you again roughly a month from now.
Oh yeah, I'll be here.
I looked at the schedule. I put the schedule together the other day, and I kind of scheduled out the next 2 or 3 months, actually. And the next time you and I are meeting, I'll be bringing the topic.
Great.
And that's going to be a month and a half, 2 months from now, so I have no idea what that topic will be yet. But I'll bring it. We'll share the notes, and maybe we can have another interesting conversation.
I hope so.
I look forward to it. If people want to find you on the internet, what could they do to do that?
You can find me on Twitter or Instagram, and I am at Works on My Machine. There is no O in Works, however. So WRKS on My Machine, all one word.
Fantastic.
And
I almost said fascinating.
Dave.
Yes.
Where can we find you?
People can find me on Twitter and Instagram at RaptorPaint. We love it when people tweet the show at Technophiles Pod. You can find the show, even though it's kind of funny. I was thinking about this last week. They're already listening to the show, so why am I saying this? But if you are so inclined, if you found the show on YouTube, know that it's also on iTunes and Google Play. If you're listening to us on iTunes and you'd like to see the video portion of this show, find us on YouTube and also through Facebook.
Smash that subscribe button if you find us through iTunes. You go to YouTube, there's a big red button that says subscribe. You're going to see that counter go up by 1.
Hey guys, remember to click like, subscribe.
Hey, mention in the comments what you'd like to see on the next episode. And rate us on iTunes. Obviously, that's going to help people find us.
So the rating on iTunes thing is kind of an important thing. iTunes uses reviews as its main variable in its algorithm as far as importance on a show. Anyway, so if you're inclined to do that, please remember to go review us. That'd be awesome. If you have something that you'd like for us to talk about, I think the best way to get in touch with us is probably to tweet us or find us on Facebook. I do run that software that feels when Facebook messages come in, so I'm able to reply to them fairly quickly when people do that. So with that said, Alex, I think we'll get out of here. I hope you have a good couple weeks.
Yeah.
Any plans? It's finally starting to get a little warmer out.
Well, let's see. Lauren, my fiance, has a dance show coming up. So if you're in the New York City area, March 2nd and 3rd, check out Boink at boinkdance.com for all the information on how to get tickets for that. So we'll be doing that this weekend. Got some people coming out. And other than that, just getting ready for the wedding. That's about it.
That's right. Pardon me. That's right. That is coming up.
And your sister's getting married right after us. So we've got a whole summer of celebration to plan for.
It's going to be a big thing.
Oh.
It's going to be a whole big thing.
I hope that wasn't too familiar for the audience.
They're like, everyone's like, wait, what now? This is getting weird.
Oh, I got to turn it off. Human emotion.
Turn it off.
Well.
All right. Well, okay. Everybody, thanks for listening. We'll see you next week, wherein we will talk about something else that is interesting.
Way to sell it.
We don't have an outro for this show yet. We don't have a true outro. Jake and I struggled last week as well, so I'll figure something out.
Okay. Maybe we can put an
Later.
ad, right? Like, let's do an ad right now. I'll do an ad read. Coming to theaters this Friday, experience the wonders of eugenics in the smash hit Gattaca. Watch as a heartthrob burns himself alive in a kiln, usually made for, that's right, firing pots. All this and more in Gattaca, in theaters Friday. Right?
I cannot wait to see that film. Sounds like a good one.
Well, we'll see.
All right,
Probably
later,
for about 80 minutes.
I'll see you later.
Bye. So sorry.